Hello and welcome to this video. In this video I'm going to demonstrate adaptive RAG application built using LangChain, and I'll explain you the process of this application, and then we'll have a look at the demo. So whatever query user will give, that query will be analyzed first with the based on the analysis, the query will be the answer for this query will be searched via the retrieval based method, or it will be searched via a web search. So what we have mentioned over here, whatever documents are stored in the vector store, FAISSDB is being used as a vector store. The context of those documents, or the context of those documents is already been given to this query analyzer. So if the query is related to that particular subject, then it will redirect the query to this retrieval process. If the query is not related to this thing, the given subject, then it will redirect the query for a web search where we are using Tavily web search tool, and from the web search it will get the results and then generate the answer. Now when the query will be redirected towards this thing, document retrieval process, so it will be retrieved from the vector store. Then the retrieved documents will be graded if the documents are relevant or not based on the query, and if the relevance are not relevant, if the documents are not relevant, then what it will do is it will regenerate the query or rewrite the query as it is mentioned over here. The LLM will rewrite the query. There's a query transforming node which we have kept over here, and so the transformer will transform the query, and then again the relevant documents will be fetched, and if the documents are then relevant, then it will go for those documents will be used for generating the response. Once the response is generated, it is checked whether the response is hallucinated or not. If the response is hallucinated, then it will regenerate the response. If it is not hallucinated, then it will check whether the response answers the actual question. If it answers, well and good, it will be given as it will be redirected towards the end of the graph, towards the end node, and if it is not relevant, then it will again rewrite the question, and then again the retrieval process will happen. So I'll show you the graph also which we have made. So there are different nodes over here. So firstly the question will come from the user. Query analyzer will analyze the query and then redirect the query either for document retrieval or for web search. If it is redirected for web search, then it will search on the web, get the results, pass it to the generator generates the answer. Then the as per the adaptive analysis, the generated answer is being checked for hallucination. If it is hallucinated, regeneration will take place. Not hallucinated, answer will be checked. If it is the response actually answers the question, yes, well and good. No, again rewriting of the query will happen. So this is about the web search. Same as goes with retrieval process also. Retrieved documents will be graded over here. If the all the documents are relevant, then all those documents will be passed to the generator to generate the answer. If the generator response is hallucinated, then not supported output will be coming, and the generator will regenerate the response. If it is correct, if the response is correct, question answered, it will be passed to the check if the response actually answers the question. If it is answered, then it will be redirected to the end. If it does not answers, then query transformer will transform the query, and then the transform to query will be passed to the retriever again. So this is how the whole graph works, and this basic stream using Streamlit I have made this UI, I would say. So I'll just show you some demonstration, and then we'll have a look at the code. So I've noted down some queries. So this query, this is agent's query. This query will basically search the document from the retrieved documents, because it is this is the subject basically of the documents which are stored on the vector database in the vector database. So here the steps are being mentioned, whatever is happening. Yeah, so as you can see over here, the answer is generated, and these are the steps mentioned over here. So query analyzer, first the query analyzer checked if the query is relevant for to be retrieved from vector store, or it is relevant for web search. If it is, then it decides to go for to vector store. Docs retrieved from vector store. Documents are being graded for relevancy, if they are relevant or not. This retrieve doc grader does that, and then the like one by one all the documents gets graded over here. If irrelevant docs gets rejected, relevant docs get selected, then all the relevant docs will be passed for generation, and the generated response will be then checked for hallucination. If it is not hallucinated, then it will be passed to check if the response actually answers the question. If yes, then uh, it proceeds towards the end node. So that's how the first part, or I would say one part of adaptive RAG application works. I'll show the second part also, where we are putting something which is not there in the stored vector store. So stored yeah, in the vector store, so it will redirect to for web search, and it will get the data from web search. After getting the data, it will go for generation, and over this generation it will after generation it will check for hallucination, and if the response answers the question or not, and then based on that it gives the answer. You can ignore this error. So this is the answer which the model is given. Now I'll try to show you the transformation process also, where we transform the user query. So what we'll do basically is at this stage, when the application compares whether the generated response actually answers the question, we'll modify the question, and then definitely the generated answer will not generated response will not actually answer the question, and then the regeneration of a query will take place. So this will execute in the notebook. So what I'll do is firstly we have this question. So let me just execute the query. You can check the steps. No hallucination, then the response answers the question. So yes, so this is the response, basically final response generation, and this was the query water agents. Now what I'll do basically is I'll clear this output, and I'll modify the question at this stage, where at this particular stage I would say, where it checks whether the answer is question is answered or not. So at this stage what I'll do is I'll override the question. Previously the question was what are the agents. The same question will continue now also, but while checking if the generated response answers the question, what we are doing is basically we are modifying the question itself. So I'll just run this block and I'll recompile the graph, and then again we'll start with the process. Okay, so here you can see after a hallucination check, it checked that whether the response actually answers the question or not, and then it concluded that no, the response didn't answer the question, transforming the user query. And then the transformed, since the query was water agent, so the transformed query is now what is the definition of an agent. Okay, original question was what was the agent, so that was the original question that was there in the state, and then again the docs were retrieved and everything has happened. So that's how you can understand that how this is happening. Now since the question is now overwritten, so that's why the error is coming. But I hope you understood that how the query is getting transformed. Now what I'll show you is so I'll show you the same thing in LangGraph Studio now. So in the LangGraph studio, as you can see, our graph query analyzer, start query analyzer, retrieve grader, um, docs grader, then generator, then query transformer, and then web search is also there. So all the nodes and are mentioned over here, and then the edges are also displayed over here. So what I'll do is I'll put my query water agents again, and then click on submit. So from query analyzer it went to retriever, then retriever to retrieve doc grader, then generator, and yes, so that's the generated response which we have got, and is the result. So yeah, here's the result, I would say, the generation. Now what I'll do is I'll give another query so that it can do web search as well. So I'll put the same query. Query analyzer, then web search. So it decided that it has to go to the web search, and then it is now fetching the data from the web, and then it will go to generator. Generator will generate the response, check for hallucination, and then if it is not hallucinated, then it will go for cross-checking the answer if it is relevant or not, and if it is relevant, then yes, the generation has been displayed. So this is the generation as of now. So that's how I've displayed using LangChain developer also, LangChain studio also, and using this thing also, you can say Streamlit also. And this is the complete notebook code, I would say. So that's it in this video. Thank you. And these were the documents which are there in the vector store, which were first converted into embeddings, and then first splitted using the recursive character text splitter, and then converted into embeddings are stored into FAISS DB. Yeah, that's it. Thank you.